Hello, welcome to today's lesson on recapping upper and lower bounds. Okay, here's the starter then. So just a bit of a recap of some basic skills that we need to be able to do. So press pause, have a go, and then press play when you're ready for the answers. Okay, welcome back then. So for number one, all right, I'm going to do the working type over on this side. All right, so work out 4/7 of 35. So just need to remember this rule, don't we, for a fraction of a quantity, because that's what this question's asking us to do. It's always divide by the bottom and multiply by the top. Okay, so we would do 35 divided by 7, so divide by the bottom. All right, so how many 7s in 35 is 5. And then once you've done that, you always multiply this answer by the top. So 5 multiplied by 4 is 20. Okay, so 4/7 of 35 is 20. Right, for number 2, okay, it says find 16% of 160. So remember now, like it says in the title there, it's non-calc. All right, so if I was doing 16% of something, I think the best way is to do 10% first, then 5% after, and then 1% after, and just add those numbers together, right? Because that combination will give us 16%. Okay, so we should be comfortable doing this at this stage anyway. So 10%, remember, is divided by 10, so 10% would be 16. Okay, 160 divided by 10. Then 5% is just half of 10%, isn't it? So if we already know that 10% is 16, then 5% must be 8. And 1%, well, we got two choices. We can either divide 10% by another 10, or we can divide 160 by 100. We get the same answer anyway. Okay, that's 1.6. So when you add all those together then, 16 plus 8, well, that's 24. 24 plus 1.6, 25.6. Okay, so 16% of 160 is 25.6. And number 3 then, so I'll do the work inside here. Number 3 says share £42 in the ratio 3:4. Okay, so this is the one where there's 3 steps that we need to follow to be able to answer the question. Okay, step 1 is always to find the total ratio. All right, so that's literally just by adding up the numbers in the ratio. Okay, so ratio 3:4, that's a total of 7. All right, step 2 then is you divide whatever you're sharing by your total ratio. Okay, so our total ratio is 7, so we're going to divide what we're sharing, which is £42, divided by 7, which gives us 6. Okay, so that gives us what one share is. Well, this person's getting 3 shares, and this person's getting 4 shares. So step 3 then is just to multiply the one share by the numbers in the ratio. So we would do 6 times by 3 for the first one, and then 6 times by 4 for the second one. Okay, giving an answer of 18 to 24. Okay, and it's important then that you always add these two numbers together to make sure that they add whatever you started with. Okay, in this question you're asked to share £42, so if you share anything more or anything less than 42, then obviously it's a mistake. Okay, and number 4 says evaluate 0.2 times 0.3. Okay, well, we've done lots of different methods for this one before. Okay, so you can either do the long method, which is change them both into whole numbers by multiplying by 10. Okay, that gives you 6, doesn't it? And then because we've multiplied by 10 twice, we'd have to divide by 100 afterwards, so 0.06. Okay, or what you can do for that one, and we're good enough, we're smart enough to be able to do this pretty easily, is I always just say, look at the numbers in the question. Okay, we know that 2 times 3 is 6, so that's fine. But then lots of people might have written 0.6 for this one. All right, so look how many decimals there are. So how many decimal places there are in the question. So that's 2, because there's one number after the decimal point here, and there's one number after the decimal point here. Okay, so that means there has to be 2 in your answer as well. So that's a little bit of a trick of you finding out that it's 0.06 rather than just 0.6. Okay, right, moving on then. So example number 1 about upper and lower bounds. Okay, so I would press pause and copy this down, and then press play when you're ready to go through it. Okay, welcome back. It says, Mr. T draws a rectangle using his famous yellow ruler. Unfortunately, this ruler can only measure lengths correct to the nearest centimetre. I'm going to underline that because it's important, okay? The rectangle measures 4 centimetres by 3 centimetres. Calculate the biggest possible perimeter and the biggest possible area of the rectangle, okay? So step 1 in all of these questions that we do on upper and lower bounds is to find out the upper and lower bounds. Okay, so we've got two different measurements. So we've got 4 centimeters and we've got 3 centimeters. Okay, now these are measured in centimeters, look, and this is measured to the nearest centimeter. So that means to the nearest whole. Okay, so these values have been rounded to the nearest whole, or that's the same as writing the nearest one. Okay, so the nearest one. Right, the trick is to find the upper and lower bounds, isn't it? Is to do half of whatever it's been rounded to. Is the easiest way to remember it. So because this has been rounded to the nearest one, okay, we do half of 1, which is 0.5. So for the upper bounds, you would add on 0.5. For the lower bounds, you would subtract 0.5. Okay, so that means the upper bound for this 4, so the biggest possible value is 4.5, and the smallest possible value is 3.5. Okay, and the same thing for this one now. So the biggest possible value is 3.5 and the smallest possible value is 2.5. And that's got to be step 1 every single time. Find what it's been rounded to, half it, because then that's what you add or take away, and then write down what the upper and lower bounds are. Okay, because in some questions you'll have to use all of these values. Some questions you might only need the biggest, and sometimes you might need the smallest. So hopefully we can spot that in this question it says calculate the biggest possible perimeter and the biggest possible area. Okay, I'm going to say this is question A and B. Okay, so for A, the biggest possible perimeter, I'm going to write P for perimeter and then max. So this means it's the maximum perimeter. Okay, well, you just need to remember now, this is a rectangle, isn't it? To find the perimeter of a rectangle, all you do is add the sides together. So if we want the maximum possible perimeter, then we use the maximum values. Okay, so we're going to use 4.5 twice, because remember it's got 2 sides that are 4.5, and we're going to use 3.5 twice and just add them together. Okay, some of you may prefer to do 4.5 plus 4.5 plus 3.5 plus 3.5, but it gives you the same answer anyway. Okay, so the maximum perimeter, well, this is 9 here, isn't it? Yeah, 4.5 plus 4.5, and then 3.5 times 2 is 7, 9 plus 7 is 16. Okay, so the maximum possible perimeter is 16 centimeters. Right, then it also says biggest possible area. So area of a rectangle, hopefully we remember, it's just length times width. Okay, so length times width. But if we want the biggest possible area, we want to use the biggest possible values. Okay, so we're going to do area and then max. Okay, so that's the 2 biggest sides multiplied by each other. So that's 4.5 multiplied by 3.5. Okay, the upper bound for this one and the upper bound for this one. All right, so there's a couple of different ways you can work that out now, isn't it? So think about what we did in the starter if you need to, okay? Or you can change it into 45 and 35, do the box method, and then change back, okay? It's entirely up to you. I'll leave that part to you, all right? But it's 15.75 should be your answer, okay? And this one is in centimeters squared, right? This one was only perimeter, so it was just in centimeters. This one has to be centimeters squared because we're talking about area. All right, so the steps that you follow should be very similar every time. Have a look at what it's been rounded to, find out how you would work out the upper lower bounds, and then look in the question to figure out whether we need to use the upper bounds or the lower bounds, or sometimes both. Okay, right, here's the next example then. So for this example now, press pause, copy it down, and press play when you're ready. Okay, welcome back then. So some people may prefer to draw, to actually draw the shape. I didn't do it in example 1. I'm not going to do it in example 2, but if you want to draw it because you think it'll help, then that's completely fine. Okay, so it said Mr. T now draws a right angle triangle of base 6 centimeters, vertical height 8 centimeters, and slanted height 10 centimeters. Calculate the smallest possible perimeter and the smallest possible area. So I'm going to call these A and B again. Okay. So we already know from the last time now is ruler can only measure to the nearest centimeter. These are in centimeters, so we're still doing the nearest whole number, aren't we? So let's just have a look at the values that we've got to start with, and we'll write down the upper and lower bounds. Okay. So we know that nearest centimeter means the nearest whole in this case, so we're going to add on 0.5 and take away 0.5. So your upper bound here, 6.5. Lower bound is 5.5, then upper bound is 8.5, lower bound is 7.5, and then for 10, upper bound is 10.5, lower bound is 9.5. Okay, so we figured those out now. It's just deciding which ones we're going to use. Well, it should be pretty straightforward to see, shouldn't it? It says smallest for both of them, so smallest would mean the lower bounds. So we're going to be using the smallest numbers possible. Okay, so 5.5, 7.5, and 9.5. So part A, smallest possible perimeter. Okay, so this time I'm going to write P for perimeter, but then min for minimum, so the smallest possible perimeter. Okay, well, the perimeter of a shape, like we just did with a rectangle, is the distance around the outside, isn't it? Yeah, so this triangle's got 3 sides. We know what the smallest values are. So it's 5.5 centimeters. Okay. That's the smallest base, plus 7.5 centimeters, that's the smallest vertical height, plus 9.5 centimeters, that's the smallest slanted height. Okay, so the minimum perimeter, if you just add those up then, use the column method if you need to, is 22.5. So that's 22.5 centimeters. Okay, right, on to part B then. So this is area now. Minimum area, so I'm going to write A for area and then minimum. Right, so the area for the rectangle was length times width. We need to remember though, for a triangle, the area is base times height divided by 2. And this height is always vertical height, isn't it? So we want the minimum, so we're using the smallest values possible. Okay, make sure you use the right ones though, because we don't need to use all 3 of these values. All right, the base is 6, so the smallest possible value for the base is 5.5. The vertical height is 8, so the smallest possible value for the vertical height is 7.5, and then we should be dividing by 2 afterwards. Okay, so again, use the box method to work the top part out, then you can half it. All right, I'll leave that to you. Should get 20.625. Again, that's centimeters squared. Okay, so centimeters for this one, centimeters squared for this one. Okay. Right, moving on then. So it might be worth you pausing here and taking a picture of this information, because then the actual questions are on the next slide. Okay, so in each question, you need to give the measurements. The measurements are given to the nearest centimeter, and for each shape, you need to find the biggest and smallest perimeter. Then if you finish that, find the biggest and smallest area for the first 4. Okay, so I'd pause here, take a picture of this, and then when you're ready to move on, press play. And then these are the questions. Okay, so press pause here, have a go at these questions. So remember, you're doing the maximum and the minimum perimeters for all of them. If you finish that, you can do the maximum and minimum areas for the first 4. So have a go, press play when you're ready, please. Okay, welcome back then. So here are the answers now for that main task. All right, so you've got the minimum and maximum perimeters, minimum and maximum areas also for the first 4. Okay, one to be careful on, I think, is number 6. All right, so the perimeter of a circle, remember, is a circumference. So you should be doing circumference is pi, which is 3.14 times by the diameter. Okay, so that's how you would do that one. Okay, for the second question then, press pause, copy the information down and copy the diagram, have a go, and then press play when you're ready to go through the answers. Okay, welcome back then. So first of all, it says the angles in the diagram below have been measured correct to the nearest 10 degrees. Okay, so that is a slight difference from what we've done throughout the lesson. It says find the smallest and largest possible values of x. Okay, so in the main task and in the examples, we were doing measurements were in centimeters, and we were saying to the nearest centimeter. So that was the nearest one, wasn't it? In this one, it's measured, look, the angle is measured to the nearest 10 degrees. So the nearest 10, all right, remember, we halve this number, don't we, to find the upper and lower bounds. That's what we add on or take away. So when it was 1, we were adding on 0.5 or we were subtracting 0.5. Well, in this case, because it's rounded to the nearest 10, okay, well, half of 10 is 5, isn't it? So the upper bound, we should be adding 5 on, and for the lower bound, we should be subtracting 5. Okay, so this value of 70 degrees here, right, the upper bound for that is 75 degrees, and the lower bound is 65 degrees. Okay, right, in the question also then, the angles in parallel lines, so we can see that from the diagram. Okay, so there's various different ways that we can work this out. Okay, the way I did it was to say that this is a corresponding angle. Okay, so not looking at the x quite yet. Okay, I'm saying for this one that this sort of upside down f here, if that is 70 degrees, then that angle there is also 70 degrees. Okay, because it's a corresponding angle. Then what I'm looking at is these two angles together now. So the x and the 70 together, they go together next to each other, look, on a straight line. And we know that angles on a straight line add up to 180, don't they? So in normal circumstances, if I wanted just to find x, I would do 180, take away 70, okay, because they're on a straight line next to each other. But I want the smallest and largest possible values of x. And you've got to think about this a little bit now, okay? Because if you want the smallest value, okay, if you want the minimum for x, you need to do 180, because that's the whole thing, isn't it? Take away the largest value for 70. Okay, so I'll write it down and then hopefully it'll make a bit of sense. Okay, so for the minimum value of x, I'm going to do 180, take away the largest value of 70 could be, which we know is 75. That's the upper bound, isn't it? Okay, so the minimum value x could be is 105 degrees. Okay, if I want the maximum value of x, I'm still going to do 180. Okay, but I'm going to take away the minimum value. I'm going to take away the lower bound, okay, which is 65. Okay, so the maximum value that x could be is 115. So it's important to get those the right way around. Okay, if you're finding whenever you're subtracting, which is what we're doing in this question, we're subtracting from 180. If you want the minimum value, you subtract the maximum. So I'll write that down. You subtract the maximum if you want the minimum. Okay, and if you want the maximum, you subtract the minimum. Okay, because remember, the minimum value of x is the smallest value x could be. Okay, well, x being 105, which is worked out here, is smaller than x being 115, isn't it? And then the same the other way around. So the maximum value of x, we want the biggest number x could be. 115 is bigger than 105. So there's a little bit more to think about. Okay, so whenever you're subtracting, if you want the minimum value, you subtract the maximum away. And if you want the maximum value, you subtract the minimum away. Okay, so that's how you would answer that question. So thanks for listening. See you soon.